50. And so when that hits 50, remind me it's time for exit ticket in case I forget. Bye, Mike. No, we never do it. We always do it at the end of the. Because then you don't want to do anything after. Oh, I didn't exit ticket. It doesn't work. That's if I didn't get that from you, I'd be fine with that. Nobody ever wants to do any work after they do some work. Yeah. I don't remember if I started it. All right, so this is for the recording. We just went over the exit ticket possible questions. If we are finding the scale factor, we use that formula. In blue, scale factor equals final image divided by pre-image. Make sure you're matching the correct sides, we said. So in that problem, we got 2/3 or 0.6 repeating, really. Don't round that off if you're trying to compare. And then in the second problem, we just multiplied all of the sides of this original triangle times the scale factor 1.5. And that's how we got the sides of the new triangle. And we said in enlargement, the scale factor is greater than 1. Reduction, the scale factor is less than 1. All right, so now you're caught. All right, in your book pages, turn to page. Oh, what was it? Yeah. Up on me. Dilations are going to be on the exit ticket and on the community. And then what we do today is the biggest part of it. All right, so I don't care if you write it down or not, but I want you to think about what a proportion is. If you cook, you should know what a proportion is. So think about that for a minute. So we'll talk about what it is. I know. You know? Find out. You say you know, or you say it? I forgot. I know the list. I mean that is a math thing, but that's not just a math thing. Not a portion, but a proportion. Proportional or proportion, same thing. I guess same concept. So think about what proportion or proportional means. And again, if you bake, this is something you will use practically. Well, not every time you bake, but a lot of the time.
That's fine. I will hear you. Yes, but I would always do. I would have laughed.
I would have changed that. You would have made it. Hold up. The phone. Hold up. All right. So raise your hand if you think you understand the concept of either what a proportion is or just when things are proportional.
Yeah.
And you understand it well enough to explain it. That's a little tricky. You understand it well enough to explain it. So what does that mean, though? Like, if you are comparing two things, what's true about them? Are they equal? What's the use?
Differential.
They are, or what's that mean? You can't define something with proof. They what?
But just provide something.
And again, it's hard to explain.
It's correct. They make it all. I want to get it wrong.
They what?
They make it all.
Oh, they're not. They don't make it equal. We will set them equal, but it's a little more than that. All right, so this goes back to dilation. It's the same thing as dilation. When we zoom in and out, right, we said it doesn't stretch left or right. It doesn't stretch up or down. It just gets smaller. So if we took, like, just imagine this. You have a big poster-sized picture of yourself, but then you shrink it down to your phone size. If you measured the distance from ear to ear and divide it by the difference from the top of your head to your chin, that's exact symmetrical is the word too. That ratio, that fraction, that decimal, if you convert it to a decimal, that would be the same as if you took the poster and you measured from ear to ear and divided from your head to your chin. you get the exact same density. That's what a proportion is. That's actually how they create, like if you've ever wondered how they create a big mural on a wall, typically they start with something small.
of them.
They don't really just eyeball and say, yeah, I'm going to create this big giant thing. They make something smaller, figure out how big the wall is relative to whatever the size their drawing is, and then they do the math to figure out how big the pieces need to be up on the wall. Baking, how does that work in cooking? Anybody cook? You know how does that work in cooking? Yeah, but
They're requiring it.
I don't know that this is right, so if it's not right, don't worry about that. Do you know?
Oh, it depends on what you're making. Are you making
No.
cookies, imaginary cupcakes? Maybe
Brownies. I love brownies.
brownies.
So I'm putting in 2 cups of sugar, and I have no idea.
That is definitely not right.
2 cups. What would it be then? Yeah. And have you noticed how sweet brownies are? I guarantee. Well, I'm gonna make a lot of brownies.
Not that
You're
like
gonna make a lot of
instantaneous diabetes.
I bet you there's a lot of sugar in brownies.
Let me look it up.
No, don't look it up. We'll look it up later. Do not look it up. Switch phone up. Yeah, put your phone up. You know what I'm looking at, because I saw you reach for it. Well, that's because the mix you get already has sugar in it. So you may not put 2 cups of sugar in there, but the mix has sugar in it, dude. Trust me.
I wanted to make that.
It's more than you think. It may not be 2, but it's more than you think. It's not that much more than that. 24 brownies. Well, 24. Make it 24. No, I'm not saying 1 brownie. So anyway, back to what we're talking about. Now we will look it up because you're like, oh, I way too much. I bet you I'm gonna be close. What's your guess?
No, I have a question. Is it for one single tray?
24.
Am I right? We're on board.
I
Yeah.
can't.
And that's scientific right there.
That looks like
So that's the lesson now. This stops, that stops. So again, here's your physical warning. Next time we move. So again, I'm just not doing this anymore. Stop class. Make me do this. Rewrite that. I probably didn't have to do that. There we go. Now we're at 1. Stop again. Somebody moves. Doesn't matter who it is either. Not just those 2. Stop. Move. All right. So what if though I was doing a big party and I wanted to make 48 brownies? Yeah, kind of makes sense if the numbers are that easy, right? If I'm making twice as many brownies, then I need to make or use twice as much ingredient. Not super complex, right? What did we just do? What did we just do, though, relative to what we already learned? So we did an enlargement. What was our scale factor? 2, right? This lesson we're about to do is the same thing. It's using scale factor. It's going to be doing it on shapes, not cooking, although there could be word problems where they do some of this kind of stuff. We just have to figure out what is the final image, divide it by the pre-image, and again, match the sides. And then sometimes you're going to have to do that for every side because the question is going to be, are the 2 images what's called similar? If they're similar, that means every proportion would be the same every time you matched up with like 3 sides, if it's triangle, 4 if it's quadrilateral. I now want you to calculate this out. I want to make, I'll just do this. This is not super difficult either. I want to know how much ingredient I need for 36 grams. So you need tell me how much I need for sugar and how much I need for salt. 6.5. Don't say it out loud. Wrong. So yeah, I don't care about that number you said. Don't want anybody else say it out loud. If you want to talk about it, that's fine. Quietly, that's fine. But as soon as somebody yells out an answer, everybody stops. Stop saying it loud, even though the answer was wrong. So we just did kind of the same thing. I also told you what we basically did here, and the one that was easy. I'll give you a hint in like 10 seconds. But there's multiple ways to do it. But the process way would be find the scale factor. What would your scale factor be? And then use that to figure out how much ingredient you need. So now you should hopefully be able to figure it out if you were stuck. Find the scale factor and then use that to find out how much ingredient. And then there's another more conceptual way that I'll also go over, but oh shoot, I forgot to go over something in a second. We didn't finish the other lesson. I feel like that will finish. All right, we'll do that. Well, we have some time next week since I'm pushing the foot off. So I'll have to go back over that. Sure. I mean, we've it's on the video. I think we got through all of it on the recorded video, so that's posted and have everything. But I mean, we did it. We just rushed through it at the end. I think. They're really the only periodless pilot. At least now. Some of the other ones are fine.
So are we the loudest class?
No. Believe it or not, no. Fifth period is by far. First of all, it's got the most kids. It's got like 28 kids. Well, and some of his good friends are also in it. And Ashton is in it. So if anybody is Ashton, now you know. Now you know, yeah, say no more.
That's
Freshman, cadence, and this.
and you got like
Yeah, Caden is in there. Other Caden. I have two Cadens. All right. So did anybody do it another way besides the scale factor way? So there is a like kind of an intuitive way that's pretty quick, gets you the same answer. Did you do it the scale factor? Okay, so let's do that. So what I say you do first, because we need to find the scale factor. Well, how do we find the scale factor? We're going to do that on exit day. You better not do that. Final. So in this case, there's not an image, so it'd just be final number we want. That's going to be 36 is our final, divided by our starting or pre. So what do you get? And I would convert that to a decimal. I mean, you can use the fraction button. So 1.5 is our K, right? Well, now I need to, and again, if you don't truly understand what this means, it's an enlargement. I need to enlarge. I need to scale up the ingredients. I need to enlarge the ingredients, right? So what do I do with the scale factor? 12 times both. Like I need to scale up these two numbers. So I need to say, okay, well, I need to enlarge the sugar. So 1.5 times 2. I need to enlarge, make more, or use more salt. So 1 times 1.5. So that's the process. If you are scaling, creating, again, we're going to probably do more problems from what I saw in the book. More problems where you have to determine if two figures are similar. So we're going to kind of be going backwards. Oh, so I didn't do this in the other class, but since I'm recording. So for example, I would say this. Will this, anybody know another way to do that? Jacob would totally do that. And nobody did it another way? Miles, I could see Miles doing this way. Well, what do you mean? So what would you do? So again, it's all proportional. So what Sora just said is correct. If I doubled this, we said it'd be 48, right? Well, 30, and that would be 4 and 2, right? Well, 36 is halfway in between 24 and 48, right? So I need ingredients that are halfway between 2 and 4 and halfway between 1 and 2. So 3 is halfway between 2 and 4. 1.5 is halfway between 1 and 2. If you don't understand that, don't worry about it. You got another process. Here's another way you can do it. What if I wanted 12 rounding? What would I do?
Yeah.
So if I want half the brownies, what do I need here? 1. Here, I'll write it small. I think you'll be good. So that's 12 brownies, right? 1 cup of sugar. I just cut them in half. You got that. Well, how many sets or groups of 12 do I need to do to make 36? I'll just multiply these by 3. 3. 1 times 3 is 3. 3 times 0.5 is 1.5. So I don't care how you do it. You want to memorize formulas and a process, then solve for the scale factor, multiply the scale factor times the other stuff. If you get how to group it, now, if it would have been 34 brownies, that wouldn't have worked. Because then I don't have even groups of 12 that I can use to make my final batch of brownies. So you can't always do it that way, but even on the district and state stuff, I think they will oftentimes give you problems where you can use multiple methods. So I feel like that's probably a way that will work a lot of the time. I normally give you something that you can do multiple methods on the quizzes as well. Any questions in on that? So we're going to use this concept, and that's not the lesson really. We're going to be dealing with shapes, but it's the concept you need to understand. So turn to, what did they say? 80, I think. I think it's page 80. Somebody tell us when they get there if it's 80. Is it 79? Where it says lesson 2, similar polygons? All right, page 79. So again, we've done some of this concept. I'm going to go through it pretty fast. We did the biggest piece of the concept. Some of this is just definitions. So we are now doing what is called a similarity transformation. All that means is we're doing a dilation. We're going to take some scale factor, enlarge, reduce it, or we're going to already have 2 images, and we're going to have to figure out what the scale factor is and whether or not they're similar images, whether or not the images are in proportion. If the images are similar, so this is the definition of a similar transformation or similar polygons. If they are similar, then all the sides are in the same proportion. So the scale factor, but if you took the sides and you measured them and you found the scale factor of all the sides, so 3 times if it's triangle, 4 if it's quadrilateral, 5 if it's got 5 sides, all of those proportions, if you convert them into decimals, all of those decimals would be the exact same number. The scale factor would be the exact same number for all the sides. That's the definition of similar figure. Or they give you one that says, if I take an original image, if I take an original image, ABC, and if I do some combination of transformations, so in this case, they flipped it. So what is a flip? They reflected it. Now you will get questions like this, I know for a fact, on district and EOC stuff, where they just give you 2 shapes and they say which series of transformations will map the pre-image onto the image. So you would have to say it's reflected, and they don't even give you it on a graph, like it's literally just like this. So that's a reflection. It's not a rotation, because if it was a rotation, C would be on the left side. So it's a reflection, then what? Translation, and then what do they have to do to get that yellow highlighted triangle on top of the other one, the last piece? Then you dilate, then you make it larger, you make it larger. So they're guaranteed you're gonna have that. I don't typically do that. Well, I probably should. That's an easy multiple choice. Maybe I will. And it shouldn't be super, super difficult if you kind of know what you're talking about. Multiple choice. So that's the real definition of similar figures, is that you can do a series of transformations and map the pre-image exactly on top of the image. The other one that I told you is how, you can also do it just if the scale factor between all the matching sides is the same exact number, then they're similar. And that's where most of the problems are going to have, like those problems will be the math problems. Let's see. So we kind of talked about that. We're going to do examples, so I'm not going to spend too much time on that. How do we match up sides of shapes if we're trying to see if they're congruent or similar? How do we match up angles and sides? Like say this angle matches that angle, this side matches that side. Well, they won't always be in, those won't always be in there. They won't be in there actually, because how do we just know this angle is the matching angle for that, or the really kind of the word is corresponding, but this angle is the one that's supposed to be the same as that one. Can't always do it visually. Sometimes you can. Yeah. How's it right there?
Is it
That's
the
why
color?
I need symbols.
Like the letters, like A matches up with W, with U.
You have to use the letters. Again, you might use it. You might visually look at the shape and say, well, that angle goes there. And you might get it right, but you also might get it wrong. Especially when I create a quiz, because I want you to use the letters. So I create a picture that you can't really tell by using just the visual. Angle A would match up with angle W. Angle B would match up with angle X. C would match up with Y. If we did sides, if we're trying to compare matching sides, side AB would match up with side WX. And then you just match them up using, the letters that are first and second, second and third, third and fourth, and then typically first and last. So you have to do it using the letters. So we're kind of coming back to that. This symbol right here is how you make a symbol for similar figures. So they will not be the same size, but all of the angles will be the same. Remember, we said if we zoom in and out of a triangle, the angles don't change, the sides change. That was back when we said AAA does not prove congruence, remember? That one didn't prove congruence, but we did say the angles don't change, but the sides do, so they're not congruent. This does prove similarity. If the angles are the same, then the figures are the same. They're similar. Not congruent necessarily, but similar. So that's that symbol. We'll get to that other thing in a minute, so I'm not spending more time on that. Oh, we did these properties before. We said something like angle 1, we use congruent, but it also applies to similarity. We said angle 1 was congruent to angle 1. Well, I mean, that kind of seemed pretty obvious, but we needed to know that because in some proofs, you have to use the same angle in two different figures and say, well, I know those two are congruent. Like, oh, actually, here's one here. If we did a proof somehow with this figure right here, and we have this little triangle in yellow and the big triangle, angle D is the same angle for both of them. So we would say in a proof, angle D is congruent to angle D. That's how we know they have at least one congruent angle. Let's see what else. So this one was angle 1, something like this. Angle 1, this is what we did before. It's the same exact thing, only just similar over here. If angle 1 is congruent to angle 2, then angle 2 would have to be congruent to angle 1. And then the most complex one involved 3 angles, angle 2, and angle 2 is congruent to angle 3. Then we said, well, that must mean angle 1 is congruent to angle 3. So you will see those potentially on EOC. I'm not doing any more with proofs. Here's how you remember them. That's what I think the way we do. This is probably the easiest one, right? Something's congruent to itself. That's probably second easiest, right? And that's probably the third easiest. That's the order. Alphabetic order, RST. That's how you remember. They go in alphabetic order. These go in order from the easiest to the most. So that's all I'm worried about because remember you'll be choosing from a drop down if there is any stuff on proofs on the EOC. So now let's get to more of what you'll see on my quiz. Yeah, we got to wrap it up in 6 minutes, which is, I think we're good. Go ahead and do example 1 in the check problem. Should be able to do it now. Remember, you're using the letters and the name. Yes, now. So do not look at what they've done. Only look at this. Everything else is them solving it. So only look at that part right there. Try to do it on your own. I want you to write the angle. Remember, the angles are congruent. But then I want you to write the proportions, like which side does AD match up with? Which side does DC match up with? Which side does BC match up with? And which side does AB match up with? And you're going to make that a fraction, like one side will go on the top, one side will go on the bottom. And we don't know which one is pre-image or image, so it doesn't matter which one's one. As long as you always flip that triangle or that type. That's it. Forgot to fill 6. Tune out for this. Super challenging stuff. Unless you don't continue. Actually, can I zoom in anymore? Oh no, definitely can't. See if I can zoom in any here. It's gonna mess it up. All right, so angles should be pretty simple. You're just matching up the first letter with first letter, second letter, second letter. So what is A congruent to? What is B congruent to? C and D. All right, so angles should not be difficult. Sides shouldn't be difficult either, but they're a little trickier. And the way you write them is the most important thing. Angles, not so much because you're only dealing with one angle and one angle. In the sides, you're making a proportion. So you're kind of putting two sides in the same number. It's basically a fraction. So AB is the blue. What does that match up with? And then I'll just go to A. I don't know what their order is, but AD matches up with what? Again, I don't, yeah, there it's the same side, so that's fine. Black DC. RS, is that what I'm hearing? SR, RS, whatever, same thing. And what's the last one? BC. All right, so here's the big concept. If they are similar figures, when you put numbers into all of those sides, which they didn't give you numbers in this one, you put numbers into all of those sides, just replace them. And then if you divide out and you say, you know, top divided by bottom for all of them to get your decimal, top divided by bottom, top number, you know, bottom. That'll convert it to a decimal. If those decimals are the exact same, again, no rounding, don't round anything off. You know, the calculator will round it off at the very end. That's fine. Then they are similar figures, but every single one of them has to be the same. Every single one. If you get one, if you get a side or a pair of sides, really a proportion that is not the same as the proportion you had before, then you're done. You can say, yeah, they're not similar. So basically, the scale factor is not the same. So the scale factor would have to be the same for every single pair of matching sides. Yeah, that's why I'm just wrapping it up. I don't remember if we did one with I think we did do one with numbers in the other class, but oh no, crap. I quickly do that one. I want to know what's the proportion between the sides. As soon as you get done, start packing your stuff up. And are they similar? So when you, oh crap, yeah, that's what we have to do before we go. I'm sorry, yeah, exit. But I mean, you can still pack up. You don't need anything for just your pencil. Oh crap. You know what? We may just go over there and do that over there because that's where the calculator's. So let's do that. I'll just take a moment. So pack all your stuff when you're done. You need to figure out what is the proportion, what is the scale factor for all three pairs of matching sides. If it's the same exact decimal, then those are similar figures. If even one of them is not the same exact decimal, then they are not similar figures. I give you like 30 seconds. If you don't finish, that's fine, as long as you kind of understand the concept when I do it. Actually, I'm going to start doing it. Just write the proportion. I'll do the math for you. Yes. There's one tricky part mainly that I'm trying to point out. E and in E. And then what we got? 2, 10, 15, 12, and I mean, I will say this one's one where you don't even necessarily have to use the letters. They made it pretty easy because they gave you all of the sides. So you can just match up the smallest side. All right, so you should have come up with something like that. That's your first step. If they give you all of the numbers, which they normally will, you don't even really need the letters, the smallest side has to match up with the smallest side. Like there's no other option if they're going to be similar figures. So well, actually, I guess no, that's not true. You do have to use the letters because maybe they're not similar. If you do that, you would then divide out and you would see you got the same decimal every single time. That means they're similar. And you do have to use the letters. Don't just use the numbers because they might not be similar. So if you did it wrong and you just use the numbers, it might work when technically it shouldn't have worked. So pack all your stuff up. I will grab some exit tickets. You're going to go to B4. So I want you to only sit in the first 2 rows, right? Don't go all the way in the back. The back computers take longer because they're not used as much. Correct. Oh, I didn't know attendance. Oh, yeah. So B4, I'm going to cut through and I'll open it. There should be everything we need over there, I think. Today?
Like a big.
Let me think that down.
Like last time.
Go, guys.
Yes. Hopefully fine.
You're coming. Isaiah. You need something.
Oh,
Oh, so yeah. Like a FW meaning like the length of a line, a side or something?
Yeah.
Oh, okay.
To find that, so I write it down. But it.
If the variables are on the opposite side, yeah. Oh, yeah.
Who's the talk about that? Oh, solar.